Assalamualaikum and hello everyone. We are from Group 1 and in this video, we will be discussing on application of differentiation related rates. But before we get started, let us introduce ourselves first.
Hello, my name is Farid Azim in ISHAK. My student ID is 2021-623-576 and I'm from EH11018.
Hello, my name is RAPHAEL and I am from EH110 for Group A. My matrix number is 2021892286.
Hi, my name is ANYSIA MYRA, ANAK Nicholas. My matrix number is 2021845788 and I'm from Group EH11018.
I'm DAYANG SYAZANA BUTHAMAM. My student ID is 2021857032 and I'm from EH11018. We will be covering these parts in this video: differentiation, application of differentiation, related rates, problem statement, solution, conclusion, and lastly, references.
We are going to start the slides with what is differentiation. Differentiation is a process of finding the derivative or rate of change of a function. For example, if y equals to fx, then dy dx is equal to f prime x. Next, we have application of differentiation. Firstly, we have maximum and minimum values. Maxima and minima are critical points on graph and can be found by the first derivative and the second derivative. Next, we have linear approximation. A linear approximation is an approximation of a general function using a linear function. Thirdly, we have derivative and the shape of the graph. The shape of graph may be found by taking derivative to tell you slope and concavity. Besides that, differentiation is also used in business. For instance, we can calculate profit and loss using graph. Next, we have the seismology. Differentiation is used to find the range of magnitudes of the earthquake. Thirdly, we have medicine and health. Differentiation is used for body temperature fluctuation. Fourthly, physics. Physics uses derivative to derive equations. Last but not least, speed trap. Differentiation is used to determine the speed or distance covered, such as miles per hour or kilometer per hour.
Problems with related rates involve two or more variables changing at the same time, possibly at different rates. To do this, usually you need to set up an equation relating two variables and take the derivative of equation with respect to time. You need to know the general formula as it will be used to make equation for the problem statement. You also need to know how to find the total surface area for the object. Related rates problem is a problem in which you know one of the rate of change, let's say dx over dt, and you want to find the other rate, let's say dy over dt. If y is written in terms of x, using the chain rule, dy over dt can be obtained as dy over dt is equal to dy over dx times dy over dt. So this is our problem statement. Nabila wants to make a chocolate bar with the dimensions of 8x cm times 4x cm times x cm for her brownies cake. If the surface area of the chocolate bar is melting at a constant of 4 cm square per second, find the rate of change of the volume if the volume is 256 cm cubed.
To find the answer, extract all information from the problem statement. For the dimension of the chocolate bar is 8x times 4x times x. The chocolate bar is melting. This indicates the surface area of the chocolate bar is decreasing. So the dA over dt is in negative sign. That means dA over dt is negative 4 cm square per second. Analyze the problem statement. From the problem statement, we need to find dV over dt when the volume is equals to 256 centimeter cube. Find the volume of the chocolate bar. V is equals to the dimension that we get from the problem statement, which is 32x to the power of 3. Differentiate V with respect to x, which is dV over dx is equal to 96x to the power of 2. To find the value of the x, substitute V, which is equal to 32x to the power of 3 equals to 256, and we can get x equals to 2. In order to solve the problem statement, apply two formula of the chain rule. First is dV over dt equals to dV over dx times dx over dt, and the second is dA over dt equals to dA over dx times dx over dt. Find the total surface area of the chocolate bar. A equals to 88x to the power of 2. Differentiate A with respect to x, and we can get 176x.
Now that we have obtained the value of dA over dt, which is negative 4 centimeters squared per second, and the value of dA over dx, which is 176x, we can now substitute these values into equation B. By solving the equation, we get that dx over dt is equals to negative 1 over 44x. The next and last step is to gather all the information we have obtained from the past calculations. As you can see, we have dv over dx, which is 96x squared, dx over dt, which is negative 1 over 44x, and x equals to 2. To get the final answer, substitute these values into equation A. By solving this equation, we will get to the final answer, which is negative 4.36 centimeter cube per second. In conclusion, to find rate of change in volume, dV over dt, you must apply or use the chain rule, which is dV over dt equals to dV over dx times dx over dt. To solve the question, you have to follow the steps below. First, find the volume of the chocolate and the value of x. Differentiate the volume so that you can get dV over dx. Second, find the total surface area of the chocolate and differentiate the answer that you get so that we can find dA over dx. Third, apply the formula of chain rule, dA over dt equals to dA over dx times dx over dt, and substitute the values you get to find dx over dt. Lastly, use the chain rule formula and substitute the value of dV over dx and dx over dt so you can get dV over dt. In conclusion, Nabila must apply the suitable method so she can find the rate of change of the volume of her chocolate. From the final answer, we can conclude that the volume of the chocolate bar is decreasing at the rate of 4.36 centimeter cube per second when the volume is 256 centimeter cube. These are the references that we have used to complete this assignment. And that is all from us. Thank you for watching our video.